Alright, for this problem we're doing the practice problem number 5 from the search and rescue activity from today. While training for breeding season, a 380-gram male squirrel does 32 push-ups in a minute, displacing its center of mass by a distance of 8.5 centimeters for each push-up. Determine the total work done on the squirrel while moving upward 32 times. You can find these questions in School Loop as well. In this question we have a mass of 380 grams, a distance of 8.5 centimeters, and that occurs 32 times. If you're looking at what the question is asking for, it is asking for work, and immediately you can go and use the equation work is equal to force times distance. Now, the reason why I chose this equation rather than the work is equal to the change in energy equation, you don't want to use this equation for this question, is because you're given a distance. If you're given a distance, you have 8.5 centimeters here, you probably want to use the equation that uses distance. Now, the other thing is, well, I don't have a force, but I do have a mass. In every single case where you have an object move up, the force that it takes to move that object up is the force of gravity. So you are opposing this force of gravity. This upwards force has to equal Fg is equal to m times g, where in this case g is equal to 10 meters per second squared. So once we calculate the force, which is going to be m times g, you can use that force in this equation for work. But before we do that, you have to take a look at the units that are in the givens, and it is 380 grams and 8.5 centimeters. Those aren't the right units that we use, so we have to do a little bit of converting. If you're converting 380 grams, you have to convert it to kilograms. What you know is there are 1,000 grams in every kilogram. So you have to take 380 and divide it by 1,000. And an easy way to do that is just move the decimal place over 3 times so that you get a new mass of 0.38 kg. For a distance, you know, or you should know, that there are 100 centimeters in a meter. So you have to divide 8.5 divided by 100. Easy way to do this is just move the decimal place over 2 places. So you get a converted distance of 0.085 meters. Alright. From there, now we can plug in all our givens to find the work that we do for one push-up. So for one push-up, you have work is equal to force times distance. In this case, it's mass times gravity. So we plug in work is equal to 0.38 times 10 times 0.085. And you should get, I don't know, I have to take a look at this. What do you get for this? What's the number? What's the number? Just say it. 0.38. This is square one. 10 point. No. Without 32 times for push-up. 0.323. All right. And then to get the final answer, since this is for one push-up, you have to multiply this 0.323 by 32, and you get a final answer of 10.336 joules. And this rounds to 10 joules.